Hello students, welcome to today's lesson. Right, today we'll introduce ourselves into what we call the quadratic formula. We need to produce it, and after we need to know how we can use it to solve quadratic equations. How I'll take you through in order to produce the quadratic formula, thus deriving quadratic formula. I'll take it in the simple way, that is, I'll use the normal example by the method of the perfect square to come up with this quadratic formula. More importantly, what I'm trying to say is just like if you want to drive this quadratic formula down, the main mechanism that you can use, that is the knowledge of which that you can use to come up with the formula, is the knowledge of the completing of the square. It's more like the way you are solving the quadratic equation by completing the square. Right, but in this case, it means you'll be solving a quadratic equation which is in that form, a form of the quadratic form which is ax squared plus bx plus c is equal to 0. So it's more like we're going to solve this equation, where we always consider the letter a, b, and c as constants, because this is just like general, because the formula that we're going to drive here, it will mean for all kinds of the quadratic equations as such. So how do we come up with the formula that can be used to solve quadratic equations in this case? So what I'll do here, I'll have a little example where we're going to use the method of the completing of the square to solve it directly, while on the other side, I'll be also solving the quadratic equation of this form in order to come up with the value of x. So the value of x that I obtain from this form of the quadratic equation, that it will be the formula itself. But how to come up with that one? Let us have a little example of the quadratic equation, what we need to solve using the perfect square. That's the completing of the square as such. So the example that I have here is this one. Solve the equation, which is 2x minus 7x minus 4 is equal to 0. While the other side, it'd be like solving the equation that is a x squared plus bx plus c is equal to 0. So we'll be like having two equations here. The direct one, which is an example of the general form. Right, so here we'll solve it directly. The way I'll do here is what I'll also do here. How I'll be interacting up with the numbers or constant, like say 2, 7, and 4 into solving for x. That's what I'll do the same here for a, b, and c. Because here a, b, and c, they all represent the constant as it is in here. So in short, to form quadratic formula, you use the same mechanisms of solving quadratic equation by perfect square. So now, if this is the example we have at large, if someone asks you to solve this one by completing of the square, this is the way it will go. Right. What you do first here in this equation, from what we discussed, let's say yesterday or the other day we met, we always consider first of all the term. This is the quadratic term, of course. That is 2x squared minus 7x minus 4. We consider the coefficient of the x squared. We always make it to be 1. Like in this case, it is a 2, so you have to make this one to be a 1. So what I said was just like, if you like to make the coefficient of x squared, which is the variable of the quadratic term, to be 1, it means you have to divide by that same coefficient. So, but when you're dividing, you have to divide that one throughout, not only for that quadratic term. So here for stage 1, we have got here 2 dividing here, there, and that. From this, what we get is this one here. So just like 2x squared minus 7x minus 4 is equal to 0, divided by 2 throughout, we are getting that is x squared minus 7 over 2x minus 2 is equal to 0. So the same here, I will regard a, b, c as again constants. So here, if the coefficient of x squared is a, so I'll consider this a as a 2. So So when here, if I'm dividing by 2 throughout, then here again, it will be A that will be dividing throughout. So here it will be like this stage here, it will be matched with this one here to have a situation like A x squared divided by A plus B x divided by A plus C divided by A, and the other side we also have like a 0 just for formality's sake, though we know for sure this will still just give us a 0, like that. So what we'll get from here is simply that A and A they will cancel to get x squared plus, then this cannot get into that, we'll leave it as a B over A, then we have got x the variable, and we go on for this one too. Those are unlike terms which cannot be simplified, so we leave it like C over A. But for the C over A, remember these were representing real numbers for the constants, so which means if these were real numbers, what we may obtain here, it will be a number itself, like what we have in here, like the 7 over 2 as such. So on this side here, we get a 0. Right, so you can be able to see here, step number 1, dividing by A throughout, coefficient of x squared, is as good as you are dividing here again also by 2 in order to omit the coefficient of x squared. So that's what we're doing here. Right, stage number 2, after dividing by 2, where now we are obtaining this type of a situation, an equation now without the 2 being the coefficient of the x squared. The next step that we said is just a matter of transferring this to now a constant number to the right hand side, so that if you just remain up with the 2-termed quadratic expression on the left hand side, of which I think you remember that the aim for this is to make it as a perfect square. So if I'm transferring 2 to this side, here you'd see that a number 2 is just having no x. So the same here, you'll be able to see that out of the 1, 2, 3 terms, you have got C over A, which has got no x as such. So it means here, if I'm transferring 2 to the right hand side, to have it now a negative, so I'll also do the same here. I'll transfer this one to that side. So here it means I've got x squared plus B over A x is equal to negative C over A. That's what we have there. Right. Now, if you look at this stage now and this stage now, they're almost the same. Next, what are we going to do to this one now? The left-hand expression. So what we do here is the same that we're going to do here. Now, what do? We make this one as a perfect square. So we're also going to make this one as a perfect square. So what we there is just like you find something that can be added here to make the perfect square. So I said you consider the coefficient of the non-quadratic term, which is 7 over 2. That one has to be multiplied by half or divided by 2. That one is supposed to be added here. So it means the same here again. Also do the same. We're also going to consider the coefficient of the non-quadratic term, which is B over A. That also should be multiplied by half. So here it means you have got this is a negative 7 over 2 is multiplied by half, then you square it. So the same here, we'll also have this situation, B over A, x, and that one should be added with that is now half multiplied by B over A, and that should be squared. So from what I said, if you're adding a term on one side of the equation, you should also do the same on the other side to balance up the equation. So we have got this one added to this. So also adding this one to the left-hand side is the same situation that we have here. So here we also do the same on this right-hand side. We have got our negative C over A, and this one will be added with what we have here, which is just like half multiplied by B over A, that is squared. So you can see what I do here is the same that we do here. Right, but only that here we are referring into the what? Form of the quadratic term, because we'd like to find something that is general, fitting all the what? Quadratic equations. Right, so now from that part, let's try to simplify where necessary. And you'll be able to see that here, you can really multiply this one by this one, you give it a 4, and 7 is on top there, you are squaring it up. And here you can also multiply by that one, you get negative 7 over 4, you are squaring it up. So the same we can also do here. What we have here, it will be now x squared plus B over A. Then this is x plus what we get there is just like b over 2a. That one should be squared. And it goes on to the right hand side, negative c over a plus the sum. That's just like what you got or you obtain on the left hand side here. You also get it from here. That's 1 times b, you get a b, and also it will be 2 times a, you get what? That is 2a, and that should be squared. So what I do here is the same step that is also found on the other side. Right. Now, from here, what are we going to do? We're going to simplify this one. Just a matter of taking the square of negative 7 over 4, because here is the power 2, and this gives us 14 over 16. The same here we get, 49 over 16. And the same here we also get 49 over 16. We are squaring this, we are also squaring that. So we get this, we square that one, we get that. So now, on this side here, what we are squaring is this. So this is the same as this one is also in the bracket. So what do? We also do the same and have it x squared plus b over a x plus what you get from there, it will be now b squared over that is what? 4a squared. Right. And when you go to this other side, you have got negative c over a plus b squared over 4a squared. That's the way to be. Now, if I'll go back to the real example, you'll see that what I have on this step is the same like what I have here. Now, what for then? You tell me now that I have to factorize this one here. Already this now must be a perfect square. So what am I going to do? I need to factorize this one. Obviously, I expect to have identical factors. So what is there then? In a factorize this one, I already told you the short form, just like the bracket as this one. If you factorize that, you get x minus 7 over 4 squared. That's it. So again, we'll also do the same. If I'm to factorize this one, what I'll get is just like x. Then you look at this bracketed part as what I told you. This b over 2a. So here I'll also write that was positive. I'll also write positive b over 2a. That's the way to be in this case. So this one should be covered up and squared. So to this side, it goes on. Right. So to this side here, what we have is just like this and that can be added. You can see that these two terms here, they don't have what? A variable x is as good as what you have here. You have got what here? Here we have got, that is 2 representing this one here. And this 49 over 16 is representing this one there. So if I'm adding this plus this to get 81 over 16, it means the same here. I can also add this one and that one. So if I add this one plus this one, it's as good as just beginning up with a b, this one first, b squared over 4a squared, then I can end up with minus c over a. Right. So if you can try to solve that one separately, you'll be able to obtain something that looks more like this. Let's do it together here. Look here, what we obtain here. For this part, we have got b squared over that is 4a squared. Now is minus c over that is a. So get here denominator, it will be 4a squared. And this gets here, once multiplied by b squared, you get a b squared. And this minus, then we have got a here, we get what? That is 4a times c, we get negative. That's with this one now, it will be negative 4a c. Because when this gets here, you get 4a, and that 4a should multiply by c, you get negative 4ac. So you can see that when we are adding this plus this, what we have is this one here. So we write that expression like this, x plus b over 2a, then squared is the same as this one here, coming from this operation of this and that in terms of subtraction. So this one is what I'll write it here, like this, b squared minus 4ac over that is 4a squared. 4a squared, I'll write that one on top again because of space down here. So I'll rewrite it here. Look at this, right? Right, I'll take that step up. This one, this, talk of this one here, we've got x plus b over 2a, that is squared. On that side, we have what is b squared minus 4ac over that is 4a squared. That's the thing. So when you add this plus this, okay, add this one plus negative c a. C over a is as good as saying that this minus that is the same story. You get this. Right. So now, this stage here is the same stage you have it here. X minus 7 over 4 squared is as good as having x plus b over 2a squared. Is equal to 81 over 16 is as good as having this one here. Because you know what? These are expressions, so they may not look the same as the numbers we are handling there. This one is very direct. Now, from this stage, what do we do? We can add this lever from the little example here. At this stage, what we do now, we'll be thinking of isolating x. But for that x to be isolated, we need first of all to get rid of the power 2. So this one can be got rid of by taking the square root on both sides. Right. So which means if I take the square root of this one, I'll have a single termed expression. I'll have a single expression which is x minus 7 over 4. So I'll do the same here. I'll take the square root of this one. I'll have just x plus b over 2a. So what I've done on the left hand side should also be done on the right hand side. So these ones are just representing a number because this is just a constant, a constant, a constant, or constant. If you simplify that one, you operate the whole of that one, you always just going just to get up a single what? Constant number. So now if I'll take the square root on this side, I get this. So here again, I need to take the square root of this one, which should look something like this. B squared minus 4ac over 4a squared. That's what it will look like. Right. But remember what I said that time. To say when you're taking the square root of a number, remember that the square root of a number will always be in negative and positive. So it means we have got the square root of a number as a negative value and also a positive value. So here we're also going to consider both the solutions. So which means in this case, since we are operating on the expressions, it means here we may not manage first of all to get the square root of that one as easy as it is, but we're still more going to indicate that the square root of which should be positive or negative. Right. Now, from that stage, where do we go? Ideally, if you can have a closer look on the root of this expression here, you may be able to see that what we have here, this root can be split into 2 and be able to do some kind of simplification where necessary. Like say for example, as we have it here, if I write root of b squared minus 4ac over 4a squared, this is the same as writing this plus b over 2a, that's x plus b over 2a is equal to a root on top, b squared minus 4ac over the same as root of 4 what? A squared. Right. So for this one, it's not easy to take the square root of this, but the square root for this one is easily found. And you talk of the square root of 4a squared, the answer is 2a. So let us now rewrite. It means the denominator will be converted now, also will be changed into what? 2a. So what we have there then is just like a situation that will take us, we'll have, which will be x plus b over 2a is equal to, the top part you leave it, b squared minus 4ac, and have the positive and negative attached over 2a, something like that. Right. So that's it on the right hand side. Now from here, where do you go next? You are also then going to refer from the direct example here. Right. Having taken the square root on the right hand side, like that stage is the same as this stage here. We have got positive or negative square root of 81 over 16. So what we do there now is just a matter of getting the square root of this. Here it is easily done. You get it 9 over 4. So here we have also tried to simplify it, and we're getting this one here over 2a. From there, we need to transfer this constant term to the right hand side, more like terms together, so that you should be able to isolate x in this manner. So again, here we consider this one as also just like a constant number should be transferred to the right hand side, because if you operate this one, it's more like you are getting a single number in that case, so just you are getting a constant number, because we know B, C, A, and B, C, and A are representing constant number in that case. So when you simplify, it's just as good as getting a number. Right. So what do? It means this one should be transferred to that one. It be more like terms. Right. So let's see what follows if I transfer that to that side. So here it is positive when it is left hand side. When you go there, now it turns out to be negative. So here it be negative B over 2A. So this one should be added or subtracted, because there are two signs there. Minus B over 2A will be adding or subtracting. That's B squared minus 4AC over 2A. Right, that's the way to be there. Right. So when that is done, then what follows then? Just simplify, because these are what? Like terms. Like in the direct example, I've got 7 over 4 plus minus what? 9 over 4. So it means this one can be added with that, and the other side can be simplified, can be subtracted. We always like two values in this case for x, because they're coming from the two signs that we have there, which are coming because of the square root of the number, which has must be always to be positive or negative. Right. So now, if here we are also to simplify this and that, it will mean just like we have to add, we have to do the operation of this and this in relation to the positive and negative. So what we have here is just a simple situation that we are taking us in, whereby you consider this one as a fraction, this is another fraction. So it's more like you are simplifying two fractions in this case. Such that when you're simplifying the fractions, you always need to come up with the common denominator. So here, I will consider the common denominator for this fraction and that fraction as 2a. So it means I'll write here my 2a. Right. So it'll be like 2a gets into 2a. It gets how many times? 1. So that 1 should be multiplied by the numerator, which is negative b. The answer is negative b. Right. Then after, you write the sign here. This time around, we have got positive and negative. We're also going to write the positive and negative. Then you also you also consider the 2a to be divided in the same denominator. So here you have got your 2a getting 2a. The answer is still a 1. So that 1 should also be multiplied by the numerator, which in this case is the square root of b squared minus 4ac. And the answer will be the same. This into this one is 1. 1 times that, you get the same thing, which is the square root of b squared minus 4ac. Right. So if you can look here, you just have to drop the x down here like this. So it means your x comes in like equal to negative b plus minus c square root of b squared minus 4ac over 2a. Right. So at this stage, there's nothing else that we can do. What we have there, it means that is the final part. So this what we have here is a quadratic formula that we need always to consider. Right. So this is what we wanted to come up with from that common what? That's a form of the quadratic equation of ax squared plus bx plus c is equal to 0. Right. So please, students, take this one as a quadratic formula. It will always help you to solve quadratic equations, as you have also been doing with the other method as such. Please consider that the value of b, let me begin with a in the order b and c as the constants. Right. Or call them as numbers. So you just be substituting there, then you have got the solution as such. Right. So by this, try to link the usual way of solving quadratic by completing of the square. It's the same mechanism we use to solve the for x, but in this case, you consider the the form of the quadratic formula. Thank you very much.